In this video, we're going to look at exponent rules. So I'm going to go through these fairly quickly and then do just a few examples, starting with a to the 0. So long as a is not 0 itself, then anything to the 0th power is just 1. For example, 2 to the 0, that's 1. A to the negative p. If you have a negative exponent, that is equivalent to 1 over that same base, we'll call a, to the positive p. So for example, 3 to the minus 2, right? We can rewrite that as 1 over 3 to the positive 2. This one further simplifies because 3 squared is 9, so that is a ninth. Next, we have a to the m times a to the n. If you have the same base, different exponents, and you are multiplying, that is equivalent to adding those exponents. So that is equivalent to a to the power of m plus n. For example, 3 squared times 3 to the 4th, right? That's 2 3s times 4 more 3s. You're really just multiplying 6 3s all together. So that's equivalent to 3 to the power of 6, which doesn't really matter what that is. The point is you add the exponents. All right, a to the m over a to the n. We subtract the exponents. Whatever your numerator is, we'll call m, minus your denominator's exponent, we will call n. We subtract. So for example, 3 to the 4th divided by 3 squared, that is equivalent to, if we write it out, 3 to the power of 4 minus 2, which simplifies to 3 squared, or 9. But the point is, it is the number on top minus the number on bottom. Now, I do want to point out that that property works whether those exponents are positive, negative, fractions, decimals, integers, whatever. It always works, all of these do. All right, a to the m all to the power of n, we would multiply. That's the same as a to the m times n. That's a times there. For example, 3 squared all to the 4th power. That's like 3 squared times 3 squared times 3 squared times 3 squared. You've got a total of 8 3s, right? So that is equivalent to 3 to the 2 times 4, or 8. I'm not interested in what that number is, just how to do it, okay? A times b all to the power of n. If you want, you can split that into a product, a to the n times b to the n. So for example, 3 times 2 to the 4th. Yes, it is just 6 to the 4th, but you could also just kind of distribute, really not quite the right word, but the exponent and break it down into 3 to the 4th times 3, nope, I wrote that backwards, times 2 to the 4th. There we go, they're both to the 4th power. Okay, next we have a fraction to the nth power. That's the same as multiplying the numerator, taking that numerator to the power of n, over that denominator to the power of n. So that is equivalent to a to the n over b to the n. For example, 2/3 all to the 4th, that's equivalent to 2 to the 4th over 3 to the 4th. Now when the numbers are not too big, we could go ahead and do that. 2 times 2 times 2 times 2, 4 2 to the 4th is 16. Now 3 to the 4th, a little bit harder, but 3 squared is 9, and 9 squared is 81. Therefore, 3 to the 4th is 81. Okay, then we've got a few more properties with fractions and negative exponents. These are meant to simplify your life a little bit. So a fraction to a negative power, right? I'm going to give you a little bit of an explanation here. So that is equivalent to, if we distribute the exponent, 1 to the negative n over b to the negative n. Now, 1 to any power is just 1. And b to the negative n, we already learned, is 1 over b to the positive n. So if we multiply this big old numerator of 1 times the reciprocal of that denominator, we do just, in fact, get b to the n, right? So in other words, you flip the fraction and make the exponent positive. So we're gonna just jump from here to here when we do this example. 1/3 to the negative 2, that's 3 over 1, or just 3. Well, let's go back to white. There we go. 3 to the positive 2, okay? Which is 9, of course. All right, a to the negative n over b to the negative n. Well, now what we've kind of seen, right, is that it's sort of like something with a negative exponent goes to the bottom, and that exponent becomes positive. That's by this property up here at the top, this one. And something in the denominator that is negative, such as this b to the negative n, right, goes up to the numerator, if you want to put that over 1. And its exponent becomes positive. So what we're doing is lots of little steps all in one. Basically, if you have a negative exponent, you can put it in the denominator and make that positive. So the a to the negative n on top goes to the denominator and turns into a to the positive n. The b to the negative m on the denominator goes up to the numerator and becomes b to the positive m. Little shortcut there, save you some time, right? So 2 to the negative 3 over 3 to the negative 4, we can write that as 3 to the positive 4 over 2 to the positive 3. And then from there, you're just doing calculations, right? So 3 to the 4th, we just said that one is 81, and 2 cubed would be 8. All right, and the last property in this list, a fraction to a negative exponent. You can, in short, I'll skip the rules on this one, I'll skip the explanation, but you flip the fraction and make the exponent positive. So that is equivalent to b over a all to the power of positive n. So a fraction to a negative exponent, quick little shortcut, you flip that fraction, take its reciprocal, so it becomes 4/3 to the power of positive 2. Now we already learned we can square both the numerator and denominator, so that would turn into 4 squared, which is 16, over 3 squared, which is 9. All right, let's do a little bit of practice. Just a few examples here. We're going to simplify the following expressions, but you can see plus one more at the bottom there hanging out. All right, x to the 4th times x to the 7th. We're multiplying 4x's times another 7x's, and so we're really just adding those together. So that is equivalent to x to the 11th, and I didn't mention it, but I do hope you pause this video and try these on your own. And when you're ready, go ahead and hit restart. Now here you have some choices, right? But y to the 4th times y to the negative 7. You can still just add the exponents and say, well, hey, that's equal to y to the power of 4 plus negative 7. Well, 4 plus negative 7 is negative 3. And y to the negative 3 is 1 over y to the positive 3. So that's a nice simplification there. All right, c to the 9th over c to the 5th. We can subtract. That's equivalent to c to the 9 minus 5, or whatever the numerator is minus denominator, whether it doesn't matter which one's bigger or negative, positive, you just top minus bottom, okay? All right, so that is equal to c to the 4th for simplification. b to the 4th all to the 5th, we're going to multiply a base to a power all to another power. We multiply those two numbers, 4 times 5, to get b to the power of 20. And then 3x all cubed, we can cube both the 3 and the x. That's equivalent to 3 cubed times x cubed, a little 3 there, which simplifies to 27x cubed. And last but not least, we have a fraction to an exponent. That's equivalent to x to the 5th over 2 to the 5th. Now 2 to the 4th, we already said is 16, times 1 more 2 makes 32. So that one simplifies down to x to the 5th over 32. And that is it for exponent rules.